All right, this is solving log and exponential functions, section 5.5, part 3. And we're going to solve this function, and they have a typo on here, so I went ahead and overwrote it so that we have ln is going to be affecting that whole section of 4x plus 6, and then we're subtracting the ln of the quantity of x plus 5. So ultimately, when we have this subtraction in the middle, we know that we have a division problem that we could like smush this back into. And I realize that's a good technical term, smush. All right, so we have our natural log of 4x plus 6 over x plus 5. And that's going to equal our natural log of x. So we're going to multiply to get rid of this fractional piece. So we're going to multiply through by x plus 5 on both sides. By the way, we're able to drop the ln since both sides, everything is addressed in that ln on both sides. So go ahead and we multiply. And then we go ahead and multiply through. That's going to give us a quadratic. When we go ahead and collect these all together, that 4x becomes negative, comes over here with our 5x. That's how we get a positive 1x. This positive 6 becomes a negative 6 when we move it over. It's now set equal to 0. We can solve this. So you wind up with an x plus 3 and an x minus 2. When we have set them equal to 0, that means our x is going to be a negative 3 and our other x is going to be a positive 2. And if we were to go ahead and plug in our negative 3, in this case, and it's not immediately clear why they say that this would not work. If you take a look at the ln of negative 3 plus 5, that looks fine, right? That's our ln of 2. No problem. The problem comes here, where I have ln 4 times a negative 3. So that's going to give me a negative 12, right? Plus 6. So that's going to give me ln of negative 6. And we have said you do not have any real solutions when you have a negative number. Granted, there is a complex solution, but that does not help us when we're trying to find the real solutions. All right. And last but not least, we can go ahead and solve our equations here using these values. All right, we're going to go ahead, and it's interesting to me that we wind up with both a positive and a negative here. In this case, this actually, because we're dealing with an e, and then you have this, it winds up being a very small fraction, but it is positive. All right, so that winds up being a little different than what we've been seeing. Let me go ahead and show you what that looks like. I've got that on my calculator here. So I have e raised to the 5th times that negative 6.471. If you take a look, that gives us a very small roughly 0.04. Okay, so it's not very big, but it is positive. So we can, in fact, do this problem, and that's how we get this. All right. I wanted to make sure folks realize that there is a difference there between this circumstance and this circumstance, right? That's two very different things. All right. In this case, you can set it up so that you have one problems being solved on one of your y's and then your other problem being solved on another of your y's, and then find out where they intersect. That would probably be easiest. You could also go ahead and take some logs of things. It would start getting really ugly after a while. But this is actually probably one of the easier ways to go, especially if you have a graphing calculator handy. All right, and that is part 3.